All right, this is what I think is the hardest type of problem, word problems, because sometimes they can get a little bit long and they don't provide you an equation. So sometimes you have to know how to turn a word problem into a recursive function, as you can see in the title here. One way you can do it is you can just write out each step of the process. This isn't really turning it into a recursive function then, you're simply just solving it out as it is said. The more a little riskier but better method is to draw out the process and find a pattern and then make a function to represent the problem. The reason I say this is a little riskier is because you might make like a mistake when you're drawing out the progress. Well, you might make a mistake when you're writing out a function. So it's a little bit risky in that sense. Well, let's take a look at our problem here. So we have a cell that's placed in a jar at noon, splits into 2 cells at midnight, and this process repeats every 12 hours for each cell in the jar. How long in days will it take to have 1,000 cells or more? Okay, some things we have to know now are that it wants the answer in days, but this process repeats every 12 hours. So you know that your answer has to be, you're most likely going to solve for it in terms of 12 hours, but then you're going to have to convert it to days. So you're probably going to have to divide your answer by 2 somewhere, but we'll figure that out later. Now let's take a look at what this process is. It says it splits into 2 cells every 12 hours. So what this is saying is, okay, it starts at noon and then splits into cells at midnight. Okay, so at noon, let's say that's 0. Let's put our time here and then cells here. So at time 0, we have 1 cell. And then at midnight, we're going to say that's 1 because 12 hours have passed. We're going to put that as our 1 unit of time here. It splits into 2 cells. And then this process will repeat. So for the next one, these 2 cells are going to split into 2 more cells. So we're going to get 4. And then 8, and so on and so forth. So you might notice that, well, this looks like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Well, in that case, since we want to have 1,000 cells, 1,000 plus cells, so we have to have 2 to the power of n is equal to, or at least greater than or equal to 1,000. So for this one, I know off the top of my head that 2 to the power of 10 is 1,024. And I know after that it's going to be already greater, and below that it's going to be like 512. So we're not going to need 2 to the power of 9. We're just going to need 2 to the power of 10. So our unit of time here is 10. And then, but for our answer, we have to remember that we want how long in days. So this is 10, 12 hours. And there are 2 12-hour units in 1 day. So we're going to divide our answer 10 by 2. And we're going to get 5. And that will be our answer. All right, let's take a look at another problem. So if we start with a segment length 16, and okay, I'm going to underline this. So it's 16 centimeters at first. And we have a single segment, 1 segment. At each end, draw a segment half as long. So at each end, so that's there's there's 2 ends to a line, sorry. And it's going to be half as long, perpendicular to the original segment and intersecting at the new segment's midpoint. What this is saying is you draw segment 16. At each end, draw a segment half as long, perpendicular like so. So this is the midpoint. And then if this process is continued infinitely, a fractal is created. Continuing counting the original segment at stage 1, how many segments are added during the 5th stage? Okay, notice I underlined added here. It's not asking for total, it's not asking for the length of the segment. So actually we don't even have to know that this is 16 centimeters or that this is half as long. We just need to know how many segments are added. Okay, so if I draw this out, it's gonna look something like that for our next stage, and then for our next stage. All right, and then this is gonna continue. But we don't wanna count how many there are total. So let's see how many I added. All right, I'm gonna undo all this. Oh, okay, don't wanna undo that. I'm gonna erase these. So this is the original segment. This is, we're gonna see this is 1. And then at step 2, this is gonna become here. So actually I'm gonna draw this in a different color. So this is our original segment. And then these are the segments we added. And then in step 3, this was from last time. And we're gonna add these segments. In step 4, we're gonna have this. And the segments we're gonna add gonna be here. All right, so let's see if we can find any patterns. Well, it seems that we have just 1 here, and we added 2, and here we have added 4, here we added 8. Well, kind of like the last one, rather coincidence this time. We're going for 2 powers of 2 again, except this time it doesn't seem like this is 2 to the power of 1, but it still is in 2 powers of 2, and these are consecutive powers of 2. So let's start taking a look. So maybe this is 2 to the power of I minus 1 if we say that I is equal to these numbers here, then maybe this is 2 to the power of I minus 1. So this would be 0. 2 to the power of 0 is indeed 1. This would be 1. I minus 1 would be 1 here, I should say. And this would 2 to the power of 1 is 2. 3 minus 1 is 2. 2 to the power of 2 is 4. So that seems like the right pattern. So how many segments are added in the 5th stage? Then we can write our equation as, well, actually I already have our equation here. So at stage I, the number of segments added, we're going to call that f of n. Oh, I is the variable used. We're going to say that's 2 to the power of I minus 1. So if this was 5, 2 to the power of 5 minus 1 would be 2 to the power of 4, which is 16. So that's how we know that the segments added in the 5th stage, 16 total. And that'll be our answer. You can even check that here. Like this is the 4th stage, and you can just like add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now that'd be if you use the method 1 from the earlier slide, just draw it out, which is perfectly fine too. All right, thanks for watching today's video.